Hello and welcome to another video, and I've finally found a linear regression correlation question which looks slightly different, which is nice for me because it doesn't look too dull. I just like the fact that I'm going to do a hypothesis test with coded values because I'm going to have to do a little bit of thinking, remind myself how that works. But I don't think it works any differently actually thinking about it. But anyway, let's have a good look at this. Anna is investigating the relationship between exercise and resting heart rate. She takes a random sample of 19 people, N is 19, in a year, and records for each person their resting heart rate and the number of minutes spent exercising. So here's the results, yeah? Now, this looks kind of like an exponential curve to me. So I'm guessing what they want here when they say interpret the nature of relationship between H and M, I'm going to say H and M appear to be in an exponential relationship. Yeah, you could even say it's a negative exponential relationship actually. I'll check this at the end. Like I say, on these kinds of questions, particularly with stats, I find it so fussy that I do like to answer it and then check my answer to see if my answer meets their strict conditions on the fussiness. But yeah, it appears to be an exponential relationship. Exponential relationships will typically make the dots look something like that, but also, as we've got here, something like that. You just have to basically change e to the x to e to the minus x and plus something, like which is just your, like it will be the y-intercept on the end. So, sorry if I'm not making myself very clear. If this is y equals e to the x, well, when you get y equals e to the minus x, it just reflects it in the y-axis, making it appear like this. But yeah, sorry, because the x coordinates, sorry, I reflected it in the wrong axis. Here, the x coordinates have gone from positive to negative, and as that's going down the back here, when you reflect it, it looks something like that, yeah? And so it looks like a negative exponential relationship, really. I hope they will accept that. We'll see at the end. That's what I would write. Let's see what they accept, but that's always interesting at the end. Okay, the product moment correlation coefficient between x and y is minus 0. And y, x and y are log m and log h. So the data's been coded, and when you code it with logs like that, you're then expecting a straight line. And so if the correlation coefficient, which tests for linear correlation, i.e. how close it lies to a straight line, is very, very, very strong but negative, yeah? Now, that would imply that there is indeed this kind of relationship going on. Anyway, what do they want us to do? They want us to test whether or not there's significant evidence of a negative correlation. State your hypothesis clearly. Okay, H0, rho equals 0. H1, one-tailed test, rho is less than 0. They do a negative correlation every time on these as well. State the critical value used. Okay, well, it was N is 19, I think, yeah. 5%, I'm guessing. Never guess, but it's 5%. N is 19, 5%, 0.388. Yeah, I'm on the right row. 0.3887 is our critical value. And so what I'm going to say is minus 0.897 is way less and way closer to minus 1 than minus 0.3887. Yeah, and let's just state the critical value used. Let's just put CV equals minus 0.3887. Yeah. Hence, reject H, well, accept H1. I like to be positive and tell them what I'm accepting. Yeah, because it's closer to minus 1, it suggests there's correlation. Sufficient evidence to suggest negative correlation. There is negative correlation between what is a negative correlation between? Now we want to, you can say M and H. Well, no, yeah, because we're talking about a linear correlation here, I'm just going to say between X and Y. Yeah. Cool. Yeah. So it doesn't really work any different, that bit at all, because we're just looking for negative correlation between X and Y. That's what we've done. Okay, the equation of the line of best fit is this. Y equals minus 0.05x plus 1.92. And we want to write this in this format, yeah? Now, I'm going to do it the same way I did a previous year. X is log m, y is log h, yeah? This is the way I'd like to do it. Y is log h, x is log m, I think the easiest way here is to collect the logs together. I really do. You can do 10 to the power of that entire side straight away on the first go, but isn't it easier? I think it's honestly easier to just use a bit of log laws first. So take this all onto one side, log h plus 0.05 log m. There's several ways you can do these questions without a doubt. Put that up as power, so log h plus log m to the power of 0.05 equals 1.92. Combine these, you're going to get log of h times m to the 0.05, and in a bracket if you like, equals 1.92. And now we can undo the logarithm, yeah? Now remember, this is a rule I often tell people. Log base 3 of 81 is 4. Why is that true? Because 3 to the power of 4 is 81. This just kind of teaches me how to undo a logarithm. I need to do that to the power of that equals that. So I'm going to do 10 to the 1.92 equals h times m to the 0.05. Yeah? Now, what do I want this? I want this h equals, yeah? So I'm going to make this h equals by dividing through by m. So this is going to be 10 to the 1.92, apologise. Yeah. If you like, multiplied by 1 over m to the 0.05 equals h. And so if I now just use the fact that that would just make the power negative, I think I've basically got it in the format they want. So h equals, I'm just going to quickly do 10 to the power of 1.92 on my calculator. That comes to 83.2. Yeah, I'm doing it everything to 3 sig fig, times by m to the minus 0.05, and that completes the question. Yeah, I think it does anyway. Didn't ask for anything else. Yeah, got a and k as constants found. Okay, right, let's see if we got it right. Okay, I'm interested in the first answer more than anything because it's a wordy one. As the number of minutes of exercise increases, the heart rate decreases. Well, yeah, I mean, that's clear. Or the gradient of the curve is becoming flatter with increasing m, diminishing effect of additional exercise, minute of exercise. So they wanted a comment in context because I've just said it appears to be in an exponential relationship. Let me check the notes. Check the notes. Idea is one increases, the other decreases in context. Allow use of M and H, e.g. as M increases, H decreases. Do not allow negative correlation. Although there is negative correlation, association, relationship, exponential. Good. Yeah. Last thing I read, and it seems to be allowing it. Yeah. But it does show, though, that most of the time their answers are about answers in context. So it's always a good idea, it seems to me, to give answers in context in stats. They want you to talk about the spiel in the question, basically the story, the narrative which they've introduced you to. So this was a little bit risky, it seems. There we go. But I would have got the mark, just about. Okay, h0 row equals 0, h1 row is less than 0, critical value is that. See, they don't care if you do the positive or negative there because you could just do both positive or both negative. There is evidence that the product moment correlation coefficient is less than 0. Good, we got that. And then 83.17 and minus 0.05. Good. It says answer rounds to there, and yet they're very strict on 3 sig fig. So I would be, my answer, because I mean, that's the thing. My answer, what was my answer? 83.2. Yeah, I'm slightly annoyed with that because I'm pretty sure on the front cover they say that this has to be like this. Can I just check down here? MB award 5 out of 5 for A equals 83.2. Good. Yeah, good. 5 out of 5. And K equals minus 0.05. There we go. So that's all right. Okay, I hope that was useful. That wasn't a bad one, really. It was pretty good. So there you go. If they do have coding in it, it doesn't really change anything. Okay, thank you for listening. Keep up the hard work. Bye.